Welcome. Let's have a look at day 10, Hoof It of Advent of Code 2024. So I actually solved part 2 for part 1. That's why it took me much longer than it should have. Um, However, when I got to part 2, it was very easy because I had already solved it. Um, in any case, let's go over it. So what they're giving us is this grid, and they want to know, for this first part, they want to know, they call it 9 is, what do they call it? The the um, the score. So for example, they call it 0 the trailheads. A trailhead is any position that starts one or more hiking trails. So they want to know from the 0, from the trailhead, how many unique nines can you get to? Not how many ways can you get there, just how many nines can you get to? The peaks, what do they call them? I'm not sure what they call it. Well, they give it a score. A trailhead is given a score. So again, the score is determined by the number of peaks you can reach, and a peak is a 9. So again, what I was solving was the number of ways to get to the peak, not necessarily the number of peaks. And I had to read the problem over and over again until it dawned on me. Okay, so again, it's straightforward. Again, looking at this one, so let's look at the 0 here. So it can go down, but then look how many different ways it can travel to get to this 9. It can go left, then down, or 4, then down, then left. But it doesn't matter. It only reaches one peak. So this 0 can reach this peak, which is 1. This one is just 2, 3, and 4. So it has this trailhead has a score of 4, and that's the problem. Okay, so let's see how to do it. So the test data is somewhere around here. Here, we'll just use this one here. So for this test data, they tell us that the number of trailheads, or the score for all of the trailheads. So there's a bunch of zeros here, and they want us to count. When they say zeros, it's the same as synonymous with trailheads. So for each trailhead, they want to know the score for each trailhead, which means the number of peaks, and just combine all of them. So for this first example here, the score should be 36. So let's look at that here. Okay. What are we doing here? Sorry. Okay, so we open the test file as usual, and so we didn't even need this here. And then we read in the line. We strip off the new line character because these have new line characters at the end. And then we convert every element to an integer, and then I convert it to a list, and I add it to the graph. So we can just print it out here. Print star g separator equals. Let's just have a look at it. It's Python problem 10. Okay, what happened here? Oh, sorry. Okay, so this is the representation of this guy here. And the reason why we converted to integers is because we'll want to navigate this grid based on if the next cell is 1 greater than the previous cell. So again, if I didn't mention that earlier, we can only travel in a chronological order, so to speak. So 0, 1, 2, 3, 4, 5, in that manner. Okay. So then what I do here is pretty standard. I get the row and column, and I get I know I'm going to be using directions. So I set that here. Okay, so I know I'm going to have a score, and I know I'm going to print the score at the end. Now the question is, well, we'll want to start searching only when we see a 0. So what I mean by that is here. Let's go back over here. So I don't care about this 8 here or 9. What I care about is 0. So I had to search through every row. Then I search through the columns. I say, okay, starting at this guy, I'm going to try to expand and see if I can find a peak, a 9. But I'm only concerned with the zeros. That's where I want to start with. So when I do this here, I perform this nested for loop. So for every row and every column, I'm concerned with the zeros. So if g of rc equals 0, I want to perform my I'll call it DFS, my searching, starting there. And what I'll do is I'll return the score. So, and then I'll add it. Sorry. What I'll do is I'll return a set. And I'll add the length of that. So I'll say something like total plus equals the length of the set. And this set will store the different peaks that we've reached. So define row and column. So what will be the base case or the termination case? So if I'm going to change this here, sorry. If that value is a 9, then I return that location. So yes, so this means if I reach the 9, I want to return that location. But suppose another path gets there. We'll be using sets here because we want to remember, we want the unique peaks. We're not searching for the paths. We want the unique peaks that we can arrive at. And the reason why I'm using a set here is because suppose a different path arrives to that same peak. We don't want to double count it. Okay, and then we'll start it off as a result here, maybe equals an empty set, and we'll return the result. But somewhere in the middle, let's figure out what to do. So we want to search. So no matter where we are, we want to search. So if we're here, for example, in this 4, we want to search up, down, left, right. So we loop through our directions. So for dr, dc, and what are we? Endures. So we want to check. Well, first we want to set the new row and column, and we'll set it equal to the current row plus the delta r, and the current column plus the delta c, the delta column. And next we want to check if these are in the bounds of the grid. So that's why I set them here. So if this new row is greater than or equal to 0 but less than the row, and the column has the same type of bound requirements. And so what do we care about this new cell that we want to travel to? So suppose the current cell has a value of 4. Well, we want the next cell to be 5. So what is the value of the current cell? Well, it's g of RRCC. And we want to know if we add 1 to it, that should be the new guy, the neighbor, the value of the neighbor. Sorry, apologize here. So once we're in the bounds here, and once we know that the next cell is valid, meaning it's one level up, we can travel there. So let's travel there. So we'll set DFS RC. remember, we're always returning a set, so we'll say result.update whatever is returned. And lastly, we will return the result. Return the result. Oh shit, I already had that. Sorry. I think that should be good to go. Let's run it. Python. Yeah. 36. I think that was what was asked of us here. So 36. All right, great. And now we just run it for the real data. Well, I mean, you don't need to see that because your data may be different. So I think that's what I had. All right, great. All right, great. So that wasn't that bad. Okay. And now we move on to part 2. Where's that at? So part 2 is down here somewhere. Okay. Now part 2 is doing exactly what I had originally been doing for part 1. So part 1 took me much longer, 30 minutes longer than it should have. Now in this case, they want to know the number of paths. So here the 0 can reach 9 in 3 different ways. So that should be easy. So let's go over it here. So what do we want to do? So I guess what we'll do is, I don't know if I want to delete this stuff or keep it for you. We'll make a new function. Okay, we'll make a new function. So we'll call this DFS2. And it'll be pretty much the same. Now, what is the base case for DFS2? Well, we do care if we reach, we're detecting if we reach the peak. Now, if we reach a peak, we return 1. Okay, that's good to go. Now let's kind of copy this here and see how we need to modify it. Okay, so what do we need to do? Okay, so we don't want this, we want the count now. And we'll return the count. And this count will be plus equals whatever this is. So let me go over that. Maybe that was too fast. So now we travel. When we use the recursive calls, the base case. Oh, I'll make sure to update this. This is 2. So as we use the recursive calls over and over again, eventually we'll reach, if we reach the peak, we'll return 1. Otherwise, suppose we were at this here, we're at g of whatever, we're at somewhere, x and y, doesn't matter. Suppose we're at 8, just suppose. But suppose in our cells though we have so we're at 8 and we came from 7, obviously we came from 7, and then we see, okay, around us is a 3 and I don't know, 6 and a 2. So suppose we see this, we're here. So we look through all our directions, but then we notice that there are no cells from the current cell. So the current cell is 8. If 8 plus 1 is 9, but 9 doesn't equal 3. So there are no neighbors that are above 8. So this will never get called. Which means that, so we've searched all of our directions from 8, and none of them are 9. So remember, count was 0. So that means we're still returning count because this is never called. And so I just wanted to make that point. And I think that's it. We do need to adjust our bottom. Remember previously this returned a set, and we just added the unique values of the set. Let me just modify that a little bit. So I'll comment it out. I think that, and then we'll do total plus equals. Now remember, DFS2 returns an actual number, so we can just count that. So we can say DFS2 RC. And what value are we looking for? We're looking for 81. Okay, so let's run this. Oh, we're running on the, sorry. Okay, great. So that was it. This problem wasn't too hard. I could have done much better if I had understood the problem. But again, I think I mentioned this from the very beginning for part one, that sometimes, at least for myself, if the prompt is too long, I become somewhat overwhelmed, and so I just try to skim it, and maybe that contributed to my confusion or misunderstanding. So once I kept arriving at the wrong answer, I just kept trying to read it over and over again to figure out what it meant, and then it became clear that I was doing the wrong problem. Okay, but as in life or as in engineering, sometimes when you're given product requirements or project requirements, you will be given a document or even a set of documents, and you'll have to look through them and read them, and in order to determine how to develop the product or the project that is envisioned. In those cases, though, you'll have a project or product manager that you can converse with. However, sometimes, I don't want to get into that, but you should typically look at the document first and try to read it to figure out what's being asked of you. Okay, so if you found this enjoyable or likable, please consider liking or subscribing. Have a wonderful day. Take care.